This is Junior Dev. If you're in the wrong place, feel free to stay. How many of you are here for the first time? Nice, welcome, welcome. And how many of you are not here for the first time? All of you, feel free to chat to those who had their hands up before and introduce yourselves. It's great to be here. So tonight's speakers are Jenny and Andrew. So Jenny will be up first doing a lightning talk on tech debt, and Andrew will chat about pragmatic programming. So thank you to our wonderful venue sponsors, Xero. So if you see any of us wearing lanyards, feel free to ask us for any information, or if you get stuck or anything. Toilets are down the corridor to your left, and there's women's and men's. And in the event of an alarm, go down the door that you came in, and there should be a meeting point out there. For those of you who are new here or haven't joined our Slack channel, please join our Slack channel. We post updates sometimes, and it's a great place to share projects that you're working on or other things that you want to do. I'll also put this link in the Meetup for those who don't want to take it down right now. And if you'd like to speak at one of our Meetups, we have a Google form, so please fill that out as well. I'll also put this on the Slack channel if you want. Cool, welcome. First up is Jenny.
I sometimes have this problem in my
Yeah, do you want to share everything? Don't mind the technical difficulties.
Hi, sorry for the delay. So my name's Jenny, and the talk that I'm supposed to be giving is called How to Manage Technical Debt. To be honest, I don't know. There's no one solution for all. So I guess this is kind of like a how we are trying to manage technical debt presentation. So a brief introduction. My name is Jenny. I'm a software developer. I graduated software engineering from the University of Auckland, and I joined as a graduate last February, and then officially a full stack developer here at Xero. So why am I talking about tech debt? So it's not the most exciting topics of all the things you can talk about for software development, but I believe that might be the reason why I'm standing here, because it just keeps getting pushed aside because it's not as interesting as a big shiny new feature or new technologies or stuff like that. So I just wanted to share kind of our team's journey on trying to tackle these kind of issues. So the agenda, I'll first talk about what kind of is tech debt. our tech debt, as in the product that my team is currently working on, how we're trying to tackle this tech debt, the process that we've tried, and the learnings we got from this experiment. And maybe we'll have some time for questions at the end. Cool, so what is tech debt? I asked around my team, because I'm sure most of you here will have like an understanding of what tech debt is, but I'm pretty sure everyone's understandings will be a little bit different. So out of curiosity, I asked around my team, and we got things like, is it okay if I find something on the internet? Another person said technical improvements that don't contribute to functionality or bring in easily measured business value. So like user engagement numbers or subscriptions or revenue. Another person said tech debt is like a valuable piece of work, but it's been deprioritized due to constraints such as time, cost, resource, or hard deadlines. This one came from our PO. So I summarized it. He used the analogy of a home mortgage. So it's kind of like borrowing money so that you can get a house now, but knowing that you'll have to pay it off later. So it's kind of like borrowing time now, taking shortcuts, knowing that you'll have to pay this back later, and this repayment will eventually gain interest and will slow down future progress. And another one, anything that makes the PO go. So tech debt, with my extensive research, I found on the internet, technical debt is the implied cost of additional rework caused by choosing an easy solution now instead of using a better approach that would take longer. So I think the diagram below there pretty much, not the diagram, the image over there, pretty much sums up it very well. There's this person on a bike with square wheels. We know that how hard he pedals, he won't be able to get much progress, but it's just that effort of having to get up that bike and take off the square wheels and replace it with circular ones. Just that effort and time, I guess. They don't want to devote any time into that. So this table on the side, I think was quite interesting as well. So if it's got positive value and is visible, it's considered a feature. Positive value, but it's invisible, then architectural changes. Negative value and visible is the thing that we're most familiar with, so defects and bugs. And negative value and invisible, this is where the whole tech debt thing lies. So we have such an extensive knowledge and understanding of tech debt. Why do we accumulate it? Why can't we avoid it? I guess that was kind of like the question. So what I'm going to do is take you through the product that my team is working on and also the history of our team to kind of explain to you how it was inevitable that we collected tech debt for our product along the way. So the product that I'm working on is called Ask. It's within the Xero HQ product, and you guys might not be familiar with it, but it's a platform. Xero HQ is a platform for accounting practices to manage their clients. So our vision for Ask is that we want to reduce the amount of time you spend chasing your clients for information and waiting for them to respond. So basically, we want to help practices deliver better services to their clients by sending queries. And so when they send these queries, the clients can respond with the required information. We want to make these queries easy to create, edit, send, and track the progress, and pretty much just deliver a great experience to the clients as well, so to make it easy for them to respond quickly. So this is one of the pages. This is what the accountant sees. They have a list of queries down here, and they can send it off to clients such as Gill & Sons, Hat Company, IB's K-Query, and then they can see the progress of their queries. And when you click on the new Create Query button, it takes you to this page here, and you can basically ask questions to your clients and then change answer types as necessary. And then once you feel like you're ready, send it off, and then the client can then answer these queries. So this is what the client-side experience looks like. They can navigate through sections and answer the questions that the accountant asked them, and then pretty much just submit it back, and the accountant can review their answers. Now I'll go through the history of our team. So we were two very separate teams working within Xero HQ, but in different domains. So you can see on this header here, this is all part of Xero HQ, but we have a separate tab for practice and ask, so different experiences. One team was working on the practice, one team was working on ask, And then we kind of found that the amount of work coming in for practice kind of dropped down. So the people working on practice kind of helped out the people working on ask. And then we kind of dropped in and out as necessary. And then we kind of figured the amount of work required for ask kind of went up exponentially. So we thought, might as well merge the two teams and work on practice and ask together as necessary. So there we have it. This is our current team now. We have two teams that have been merged into one, and yeah, we're fully all one team now. So I kind of explained that very briefly. I wanted to explain that because I believe that had kind of an indirect effect on how we collected tech debt over time. So since we merged the two teams together, one team was working very Scrum and another was working in Kanban fashion. So we had different processes. So we had to kind of have a lot of team merge meetings and a reset day and try all these experiments to make sure that we're not, our productivity is not going down. Also, since Ask is a relatively new product, we had a lot of features coming up and hard deadlines that our PO had promised. So all of this kind of contributed to reduce velocity. And we also had the time pressure to deliver new features. So sometimes we consciously made the decision of taking shortcuts and kind of not doing it the proper way, just so that we can meet the deadlines. Also, we worked as a separate team on separate code bases initially. So we had different ways of thinking and different ways of coming up with solutions to problems. So I guess this kind of made us as one team to kind of go with the easier solution, especially with the time pressure we have, and then kind of add an investigation task to the tech debt backlog and kind of get back to it later kind of thing. So this tech debt backlog that I say, this is what it looks like. And this is how we're trying to tackle the tech debt that we have. So this is our Xero board. We have a backlog for the current sprint we're working on, and we have a backlog of features coming up. And this is a backlog purely for technical debt items that we have. The keyword here, as I mentioned in the beginning, is how we're trying to tackle tech debt. So so this is how we're doing it. We have a backlog, and it usually is formed by someone identifying an issue, or either as a team we discover something, or if we consciously make a decision to do something a faster way, then we put the item into the backlog. We notify the team before doing so everyone's aware of what's going in there. And we just create the backlog item in Jira, give it a title and description, and then we have a prioritization meeting. Now, the important part here is that it's technical. We discuss a lot of technical issues and how much time it's going to take. So it's without the product owner. We go through the backlog items and we give it a value proposition. I think this is kind of like the key idea, the key thing that the presentation's kind of wanting to talk about. The importance of this value proposition. So this is explaining to the PO why this needs to be done, because otherwise it just keeps getting pushed aside and aside, because new feature work versus invisible things that don't really have negative impact on the users. It's hard to kind of justify addressing these technical debt items. So we give it a value proposition, and then we prioritize it in the order of importance. Then we take it to the PO to review, and then things start rolling from there. So this is one example of what our tech debt items look like. It may be true, it may be not true. So retry for timeout requests. We have a title. Then we tag it with the technical debt label so we don't lose track of it and we know what it's for. And we give it a description. So currently the retry handlers are not retrying, blah, 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 blah. So we make sure everyone knows what the real issue is and why we're having this problem. And then this is, I said, the value prop, the most important part of this Jira ticket. So some of the things that we wrote down for this one was that it eliminates task cancelled error logs. It lets us focus on the important errors without having to sift through redundant, repeated error messages. And it lessens the burden on the support person, and it frees up capacity to do sprint work and resolve other real issues. So this is kind of completely different to the description above. It's very focused at the PO, something that makes the PO go, So I guess it's kind of aimed at kind of pitching that kind of importance of why this needs to be addressed. Is it working? I don't know. We've had 2 meetings up to date. I was sick, so I missed the second one. So literally have had 1 meeting to do this prioritization thing. But in that 1 meeting, we addressed almost half of all the items in the tech debt backlog. And I think we resolved about 5, I think. But it's hard to say because we're currently got another hard deadline to release this new big feature that we've been working on for a couple of months. So we're currently prioritizing this feature work over repaying the tech debt. So I think it's safe to say that it's going pretty well, but it's just the very, very initial step towards this bigger vision that we have. So it still requires a lot more thought and effort and a lot of practice, I guess. So to be continued. We're still adding to the backlog for sure. Every day we're discovering new things. So the whole process of identifying it, then notifying the team, and then putting it into the backlog. And I guess we're doing that part, but to be continued, the upcoming prioritization meetings, which will hopefully allow us to go through these, attach a value prop, and be able to kind of incorporate it into our future, into our sprint work once our big feature's been released. So I think that's pretty much it that I have. Yes?
So in your typical work week, how much time do you spend in meetings?
In our typical week?
Yeah.
That's hard to say. This week, I think half of my week is meetings, but about 5 weeks ago, like 3 hours a week. So it really depends on the time frame, because right now we've got things coming up, deadlines, like real hard deadlines that we've promised to like many stakeholders. So I guess we're trying to kind of busy period now.
In terms of identifying
Yeah.
that process, are you using any tools or are you doing it fully manually?
Yeah, it's fully manual at the moment. So once
you just find it some kind of rush.
Yeah, so usually we use our Slack channel extensively. So everything that we do, we log it into our Slack channel. So whenever someone discovers something, they put it in the Slack channel, then we start a thread and we discuss all the things, and then so no automation, unfortunately. Yeah.
You have a question. Deadlines create technical debt.
Yeah.
Right? How do you represent the cost of deadlines?
How do we represent the cost of deadlines? So do you mean? Sorry, I don't.
You set a deadline, because of that, you have to take shortcuts.
Yeah. Right.
So, like, what's the product? How is the product owner
Aware of that?
where do they deal with that?
Right. So we make sure that we don't overlook any issues during meetings. When we decide to take a shortcut, we make sure that the PO is aware of it in the initial phase. Sometimes they're like, actually, if it's going to provide more value to us in like a month's time, 2 months' time, then actually I don't think we should take the shortcut. So he is aware of all the pain points in China of technical debt, which is why he's very for us having these prioritization meetings as well. So,
is it the developers' best interest to raise tech debt tickets?
I think it's. I think some of them. I think we're very conscious of it because as a team we made a conscious decision. It's the decision that we should be addressing these early on. So I think we sometimes go searching for any things that we can find. But I think it's on the developer to find and load these. Yeah.
So was it so the team as a whole all decide to start addressing tech debt, or was it like one person saying, okay, we should start doing this, and everyone sort of has to do?
I think at one point we were like, what is wrong? Like, why are we, like, we're a relatively new product. And we're like, new products shouldn't have tech debt. What are we doing wrong? And we kind of figured like, we're kind of keep pushing it back. And we're like, why do we push it back? Because it's not important. Then why is it not important? So I think we kind of, as a team, discussed during one refinement session. And then we got to the root cause of it. We're like, because we don't have a value for it, which is why we're not prioritizing it the same as the feature work. So I think we decided, yeah, maybe we should try this experiment out. Yeah.
It's like focusing on tech debt probably slows down your velocity when it comes to pumping out features. So
Yeah.
have you received any like negative reactions from stakeholders, like product owners?
Yeah, so that's why once we have the tech debt prioritized in the backlog, what we did was with our regular like sprint work, we would kind of pull in one or two. We would kind of in the refinement session be like, oh, I think we have capacity to take on like a tech debt item. We story sized it and it's about a 2 or a 3. So I think we should be able to fit it into the sprint. So we don't like take in like the whole lot or like everybody start working on tech debt items because yeah, so we kind of work on it parallel, maybe like a 90-10 or 80-20 kind of ratio. But at the moment, it's 100% sprint work. Yeah.
You've got a really big feature coming up the next few months.
Yeah.
What's the team's action to prevent future tech debt?
I guess some things can't be prevented. So if they can't be prevented, like for example, if the deadline is tomorrow, then we can't build out like a whole new, like, I don't know, stack in like one day. So we have to take shortcuts sometimes. So I guess the important part is making sure that we identify that it could cause possible potential problems later on. So making sure we identify it and then putting it into our backlog so we don't forget about it. So I think that's the best we're doing at the moment. But, yeah.
So with tech debt, you kind of, I think the example again seems to be very explicit. You made a decision.
Yeah.
Do you see a distinction between explicit decisions in your made versus implicit ones where, for instance, you don't know what the best way of doing it is, so you make a decision and you learn later that it's
Yeah. And I think it's because of those implicit ones where we started having those discussions around what are we doing wrong kind of thing. So even the retry one, so it is a real one that we had. We've discovered it way later on after some sort of decision that we made around how to do the retry logic, whether to implement it that way or that way, to use like a handler or something. So we didn't know what the best approach is. We did it one way, then we figured out it wasn't working. So I guess as soon as we found it out, we're like, okay, it's not really having a negative impact on the users, but it is still a tech debt item. So I think we're still aware of it, but I guess the implicit ones are harder to pick up and have a delayed effect. So yeah.
Just going off that, in your current like backlog, do you have more implicit items or explicit?
I don't know everything that's on my backlog at the moment, but I reckon most of them are implicit, like things that we thought initially like, are they bugs? But they're not really bugs. So we kind of figure out later on down the track, it's like, why is this not really working as expected? Why is our list taking so long to respond? It's like, oh, because we didn't do this or didn't do that. So it is like the list is loading, but it's just taking forever to load. So I guess that kind of thing kind of goes into the yeah.
So I have two questions. First one would be, does your POs have like legal background?
Our XPO slightly did. Our current PO, I don't think he has a lot of technical, he's not from a technical background, but he does know some tech things because he has been working as a PO with developers for a while. So
If the tech debt is an architectural one,
yeah,
is it up to the developer to convince them that
mm-hmm.
it is worth it?
Yeah.
Because there's no user benefits, right?
I guess how you structure that value prop would be would determine whether the PO decides to go forward with it or not. Like with the retry one, we could have said, addressing this retry logic will give us less, error logs. Then he'll be like, so if it gives you less error logs, like what value does it have to like the users? And so kind of forcing it to, forcing yourself to come up with the positive value for the user and for the stakeholders, I guess, on how their architectural change will impact users. I mean, will it be faster, or will it help you develop faster later on, or things like that?
That's probably all the time we have for questions. If you want to ask more questions, feel free to chat to Jenny afterwards. Thanks, Jenny.
So next up we have Andrew, he's a software developer at Solnet, and he's going to be talking to us about pragmatic programming. Oh, okay, he's just getting set up now. And also we'd like to thank Ben for sponsoring the food and drinks for today. So if you get a chance, chat to Ben back there. He's and make sure to thank him for the pizza. And also Suki would like to say that she's a dingus. Okay. Yep, technical difficulties, don't worry. If you want to get a drink or bathroom break, now's probably a good time. Although we may suddenly just start to talk, so no, there is always a bit of risk.
Hi there.
Okay.
That would.
Dunno.
Just go. We kicking off? It's being recorded.
I did not.
Oh, boy.
You want to share screen?
Yes. Get my slides.
So you should be able to. Slideshow.
It's not Summer of Tech. This was at Summer of Tech. Cool, okay. Let's kick off. Yeah, this is good. So first things first. So this is not so much of a talk on technologies. It's kind of like it's a talk on best practices, ways that you should go about your work, pretty much everything here. So I want you guys to get out of this talk just some general ideas about the way that you should approach things, the way that you should conduct yourselves, and some technical stuff as well. So about me, I work for a company called Solnet. We're a digital consultancy company. Basically, companies who don't have IT departments come to us and get them to build software for them. Mostly do front end, done some back end a while ago, but mostly work on the front end. A lot of the work I've done that you may have seen is on Lotto's website and mobile app. Worked a lot on the enhanced drawer experience, which is like a a way to present to customers that they won or lost in games. I'm currently working at Sky City on a loyalty scheme for gamers. So I've got a fairly lengthy introduction, and I think that for some of you who are currently professional developers, it's probably just some of that will be quite resounding. It'll be business as usual. For those of you who are students, might be a bit of a wake-up call. And then we'll go into the topics. So we've got 6 of them here, and then I've got a few extra ones as well. Can't even, in a minute. So this is what the talk is based on. It's a book called The Pragmatic Programmer. Has anyone read it? One person. You like it? Yeah. Cool. Yeah, so I read this a couple of years ago, and it was just helped me massively, and I'm really glad I did. I recommend it to everyone. So basically, when I started working, I kind of realized that a lot of the principles that this book talks about are not implemented very well in the industry, and I think if everybody read this book and started practicing and teaching others, it would make a huge difference. So it's basically, it doesn't focus on any technology in particular, although there are coding examples. It's more about best practices, approaches, a way to think about problems, a way to solve problems, a way to work in a team, how do you present yourself in meetings, how do you get things across. 50 or so tips. Not a particularly long book, can probably read in a couple of days. And so what I've done is I've gone over, I'm going to present some of the things that they go over in the book today. Some of the things I thought that would be easy to talk about. Yeah, so I'm going to talk a bit about what it's like working in the industry. Sorry, how many people are actually developers working right now? Hands up. And how many are students? Hands up, who will be working shortly. Cool. Yep. Anyone? Okay, most of you are professional developers, so I'm sure you do. So is everyone familiar with software lifecycle methods? Agile, Kanban, waterfall. Yeah. Okay. So I'm going to say, first of all, these principles have nothing to do with quality of code. There's no association that you can find that will show you, we did Agile, therefore our code is awesome, our software is awesome. They are separate. If somebody, I hear this a lot, if somebody says, our code will be awesome because we do Agile, they probably don't know what they're talking about. Yeah. So, code quality. It's a big slide. A lot of what I want to talk about is to prevent bad code, which will lead an organization to crumble. The worst, as Jenny Lee gave in her presentation, talked about technical debt. The worse that code is, the worse the code gets. It gets harder and harder and harder to maintain, and even making really small changes can seem impossible. You tell the product owner, we can't make this button do this one thing, and they go, why can't you do it? It's just make it work, and they just don't understand that the way that it is makes it almost impossible to change if it can get really bad. So some of you have seen this already. Code can be antagonizingly awful to deal with. Really big methods, way too many parameters in methods, README files that are out of date, so you don't even know how to deploy how to build the thing right. We could list all the things that we can think of to do with bad code, but I think you guys get the idea. Yeah, code quality is extremely important. Hell. Most software that you have ever used at the code level is awful, right? But how could that be true? Well, what we experience as users, right? Games, banking software, mobile apps, what have you. What we experience, even though it might be great, has no reflection on how good the code is, right? I bet you that at Facebook right now there are massive teams working on fixing tens of thousands of error messages that are getting a second, because of some bad PHP code that was written 10 years ago, right? This kind of thing is everywhere. So how do things get so bad? Well, yeah, I mean, you have deadlines. That's always one possibility. But the main two reasons are that projects kick off, everyone's full of energy, and then after a while, deadlines can get unreasonable, and people stop caring. People have families. People go on leave. People take holidays. People quit. It can bring morale down to the point where it's very, very hard to make progress. The other reason is that there are some people that are irreplaceable. Actually, at the moment, one of the guys I'm working with at Sky City has been with the company for 11 years as one of their only back-end developers, and now he's quitting. So we have one of our other guys is going to try and replace him, but it's like, how can you absorb 11 years of knowledge in a week? All right. So this is not going to be fun. Another reason is nothing is documented, right? Very common. People run out of time. They don't document things. Documentation gets out of date. At Lotto, one of the things that we had when I started was for a prototype that never actually went live. So I spent most of my time reading something that I realized was never going to exist. So I'm sure you've all experienced this. Very common. What about something shiny and new? Another great book, Clean Code by Bob Martin, estimates 80% of programming is maintenance, right? Keeping things running, adding new features occasionally, fixing things that are bugs, or new device comes out. Hey, I11, this JavaScript thing broke. Oh, React's upgraded. There's a new problem here. It's keeping things running. It's fixing keeping alive what already exists. A lot of this is more aimed at new developers. A lot of what you do is just keeping things running. It's not so much building shiny new cool things as much as we'd like it to be. So it is true that there are some things where there are things like marketing websites where they don't need much maintenance. WordPress websites, for example, with just a few headers, they don't need updating. So there are exceptions, but generally a lot of what we do is maintenance. So there is hope. So all the stuff I've talked about is my goal for today's talk. And take it with a pinch of salt. Things aren't always that bad, but they can be, and they can be much worse. So thanks for putting up with my pretty lengthy introduction. But I wanted to stress why I'm going over the topics that I'm going over. I think you all get the idea. Code quality is everything. So our first topic is a pragmatic philosophy. So we've got 6 of these to get through. This is the first one. So first tip, just some small general points. So I want you guys to be pragmatic programmers. Pragmatic means practical, right? Be a practical programmer. When you write your code, try to take care of it, right? Think of it like an essay for school, right? Where you get criticized on formatting and choice of words and the way that it looks and feels. Try not to be, this is a tough one, try not to be intimidated by deadlines. Try to always put in the best effort that you can with the time available to making sure that the code itself is good. What makes good code? Well, we'll go into a bit of that today, but that's its own topic. You guys know pull requests? Pull requests, everyone know? Basically, I take your code and I see what you've done and I can comment on it, right? This one is swept under the rug a lot. Take your pull requests very seriously. Oftentimes when we are under duress and we don't have time, people often will take your pull request and they'll go, I don't have time really to look at this. I'm just going to approve it. And then that introduces a bug. Or worse, it introduces bad code, which later someone can't read very well. Take the approach that every line of code that you change has the opportunity for a new bug. Think about your name conventions very, very, very carefully, particularly methods. Yeah. Relentlessly refactor. Tip number 2. Everyone heard of refactoring? Raise your hand. You heard of it? Yeah, good. Well, for those that don't know, just as the process of improving code without changing its functionality. People often get this wrong. They think it means like adding things. Doesn't. It means same effect, the code is written differently, right? Follow the dry principle, right? Don't repeat yourself for everything. So what that means is any piece of logic I have, I want it to be in one place at one time. If there's any constants, any source of truths, I want them to exist in one place in the project, right? Functions and classes should have one job only. So oftentimes, this is more of a beginner's mistake. You'll write a method or a function and it'll do a whole bunch of stuff. But the way it will work is it'll do more than one job, right? When it does more than one job, we call those side effects. If you make everything just have one job, everything will be much more condensed and compact, and code will be much better to read. Try to think of consistent and sensible names for functions and variables. So if you can think of, if you need to have a local variable, which is only going to exist for a few lines, you can think of those can often be shorter, right? If you're using a for loop, you can use for I in range, whatever, that's fine. Obviously, if it's something that's going to be used elsewhere, it needs to have a more descriptive name, right? Formatting, so things like white space, tabs, the way that you lay things out, number of parameters that you can put in functions, things like that. You can get tools that can help you with those. Formatting is really important and it's often discarded. If you're into JavaScript, the one I use is Prettier and ESLint. Those help me out a lot. So Robert Martin's clean code helps a lot with that. Okay, so we'll look at an example. Can everyone see that? Yeah. It's actually a bit of a bigger monitor. Can everyone see this? Yes, no, kind of? No. All right, we might skip that. Okay, tip number 3. Don't live with broken windows. In inner cities, one broken window left unrepaired for any substantial length of time instills in the inhabitants of the building a sense of abandonment, a sense that the powers that be don't care about the building. So another window gets broken. People start littering. Graffiti appears. Serious structural damage begins. In a relatively short space of time, the building becomes damaged beyond the owner's desire to fix it, and the sense of abandonment becomes reality. Don't leave broken windows unrepaired. Fix each one as soon as it's discovered. If there's insufficient time to fix it properly, then board it up. What this comes down to is, if you see a problem, fix it, right? Anything, as we've discussed, anything that is left on its own to just wither away, it is harder and harder to change as the project goes on. Okay, some examples. You see some unneeded or commented out code, get rid of it. In fact, that's one thing that I think we all need to do. Commented out code is not code. If you come in and you see commented out code, how are you to know why it's there? Is there a comment that explains, oh, this is something that we tried and it didn't work? Or is it something that was that's replaced completely, right? If you see commented out code, it's usually a good idea to get rid of it, or in fact, not to have it at all. If you see poor or out-of-date documentation, you should change it, right? If you have to work on a code base that's bad, you will not want to work on it. Source control. Everyone familiar with source control? Use source control for everything. So one of the most important things we look for in a user interface is this undo key, a button that does all our mistakes. And that's exactly what source control is. A good source control system will let you track changes, answering questions like, who made change in the line of code? What's the difference between this version and the last week's? Which version of this code has this bug in it? What version of Java were we using 2 years ago? Right? So you guys are all, we can skip this bit a little bit, but I'll go through some more advanced Git commands that will help you. okay, that'll give you a reason to focus more on Git as being a real power tool for developers. So Git blame. Git blame will tell you exactly who made a change to a specific line in a file or to an entire file, right? So sometimes you're in a position where someone's made a change and you don't know exactly why that change was made. And sometimes the only thing you can do is to ask that person, right? Git blame will do this for you. Git diff is quite common. Git diff will just simply tell you what is the difference between X and Y. And sometimes what you want to know is, did this branch that we merged that was 6 months of work, how much did it change exactly from the development branch at the time? Right? Git diff is really useful. Git bisect. So a problem that can come up a lot is, hey, there's a bug. How did it get there? Who introduced it? Git bisect will do this, will tell you this, will give you the answer. So what it does is, you have your head, right, which is the latest commit, and then you have all the other commits after it, right? If you know a commit where the bug didn't exist, and you know a commit where it does exist, Git bisect, you say something like git in the terminal, you go git bisect good, and you give it a commit, say the head, and then you say git bisect bad. Sorry, git bisect bad would be the head. You say git bisect good, and you give it a commit where you don't have the bug. Then what it will do is Git will actually check out different versions for you and ask you to reproduce the bug. And if you can, you say git bisect bad if you can reproduce it. If you can't, you say git bisect good. What will happen is it will eventually tell you, as long as you have to reliably reproduce it, right? You have to know what you're doing to reproduce the bug. But what it will do is it will tell you the specific commit that introduced the bug. Provided that you, the other thing you want to do with Git, right? Sorry, I had one more tip there. The other thing you want to do with Git is you want to make sure that every commit you do is a small change, right? A mistake that I see a lot is people will have like massive changes in files, right? They'll change many files at a time and they'll put it into one commit, and it might complete a ticket. But the problem is that that work that they did was probably split over a few days, right? And it probably involved, it should have been done in nuggets, right? Where you achieve, oh, I got the positioning right, then I got the functionality, then I got the color, then I got this other thing, then I got this other thing, right? If everything is done in one commit, it makes it very hard to track exactly how that person solved the problem, right? And it could be that one massive commit introduces a whole lot of problems, but actually there's actually only a few lines of code which causes the problem, and actually everything else is fine. If you do commits with very small changes, it's much easier to figure out exactly what went wrong. The last one is git log, which people don't use enough. That just tells you what are the current commits. So the git log will tell you the commits that you could use for git bisect, right? To figure out bugs with the git bisect. Yep, so most of you are already professionals, so I know you know this, but every project you should be using version control, every assignment. You never know when you need a review button. Okay, stop it. Does anyone use design by contract? No one. Cool. How have you done unit tests? Not enough. A few more hands. There we go. So we'll talk about those first, and then go into design by contract. How many of you who do unit tests, who have done them, believe that they could be a waste of time, or are a waste of time? No one? Liars. Okay. So there's a bit of code. Sorry, it's a bit hard to read. It's just a function that says, takes two parameters, numerator, denominator, and returns numerator divided denominator. Beneath it is a unit test, right? So what this means is it's checking if this function works, right? My functions will divide. The way to test it is I say, does 6 divided by 2 equal 3? And I pass those parameters into my function, right? So that's about as simple a unit test you can get. With this, ignore the unit test. With our actual software, our function, can anyone see any problems with it? Yep. That's one. Anything else? Yep.
So missing a closing bracket. Yeah, and bracket is missing.
Where is there a missing bracket?
Function. So the first function is the closing bracket. And the second one.
Oh yeah, probably cut it off. Yeah, okay. Okay, so 0 denominator, anything else? Yep. Or an object or anything else, yeah. Yep, so there's a few things. If this was let's suppose we ignore our missing bracket problem. If this works, right, this will give us 100% code coverage, right? What that means is all our code will run, and our unit test will all pass because 6 divided by 2 is 3, right? Sorry, back to this. So people often get wound up in this idea of code coverage, right? What it means, so if we have 100% code coverage, people go, well, all our code does exactly what we want it to do. Well, unfortunately not. Right, because we just identified a few cases where we could break our unit test, right? So we don't ensure that if any time this function is used, it will work as we want, right? We don't want people to call us and pass 0 as a denominator, right? We just don't, right? Unit tests don't tell you this, right? They tell you all your code runs and that all your tests for them will work, but it doesn't mean that you've thought of every scenario, right? We didn't think about what if I pass 0 in or what if I pass an object in. Okay, so design by contract, so doesn't replace unit testing, but it does address some of the points that we just talked about. So question for you guys, is it the job of our function to reject the calls made with bad parameters, or is it the job of the callee to not pass bad input? What do you think?
Responsibility of the type system. The job of the function to reject value.
Okay, what else? Yeah. It does depend. So design by contract is a simple and powerful technique that, well, focuses on documenting the rights and responsibilities of software modules to ensure program correctness. So a correct program, definition of that is a program that does no more or less than what it claims to. Every part of a program is a routine. Design by contract focuses on the correctness of these routines. So let's have a look. So these are some technical terms. A precondition is what has to be true for the routine to be called, right? So for example, don't pass me 0, don't pass me a string, right? A postcondition is what the routine is guaranteed to do. So in other words, if you pass me 2 numbers, I'm going to divide them, right, one by the other. And a class of variant, which we won't look at an example of, is basically something that needs to be true, something that will go into a routine that will change, that will get mutated and needs to be true afterwards. So this is what you can, so with our function that we had earlier, this is what you can do with design by contract, right? We can specify, this framework for Java, this is a JavaScript framework called contractual, and it's got the traditional syntax of design by contract. So our pre-routine is, we'll check if the numerator and denominator are numbers, and the denominator has to be not 0, right? And then in the main block, we have our actual code, and the post routine is a check that we do every time we want it to be called, right? There's different ways that you can implement this. Sometimes what you want to do is you want this to only work for development, right? So you turn it on for development, you check, hey, is there anywhere where my functions, my classes are being used incorrectly? You can turn it on for production. It depends on what you want to do. One I'd recommend looking at for development only is Flow, for those of you who do JavaScript. There's one for Java called iContract, which I think is pretty good too. But it's something that you can, design by contract is something you can do to go along with unit tests and to make your code a lot more error-free, I guess. It's something that's not implemented that often, but it's a powerful tool. Other testing tools, so integration tests, basically, often it's API tests, but it's essentially, can this front end integrate with this back end correctly? End-to-end tests, does my program work from start to finish, right? Can I do everything that I want to do? One that's not used very often is mutation tests. Does anyone use these? Mutation tests? So there's a JavaScript framework that's pretty powerful called Striker, where you can give this a go. The good news is that you can set this up one time, you point it to your unit tests, and you don't have to touch it again. What mutation tests do is they will run your unit tests, but they will actually mutate your code, and they will see if any of your unit tests break. So it might be something like change an or to an and, change a not to a not, right, to a true. They will check if they will make mutations in your code when your tests run, and if you don't have a broken test, then you have problems with your tests, right? Debugging, second to last topic. This is a pretty short one. Just some mindsets I want to go over when we have to debug stuff, right? It's not fun, but unfortunately, it's a huge amount of what we do. When I started, I used to I think a lot of us do sometimes. We panic a bit when we're debugging, especially if there's something that's due, right? I did this a lot with my assignments. Yeah, not good. You often think to yourself, it's impossible. There's no way it can happen, right? A classic line is select must be broken, right? You're doing SQL and it doesn't work, and you think select must be broken. It's probably not broken. It's very rare that more often than not, that a library is broken or language is broken or something third party is broken, right? It's most of the time it's something that you've done which is slightly incorrect. It doesn't help if you get a bad error message though. So if you are debugging, just take a deep breath. Panicking will not help. Try and step through the code carefully and make an educated guess about what it could be. If you're working with a client or a tester, this is important. Try and educate them to provide you as much information as you can about a bug, because sometimes bugs will be reproduced one time or one time only and never again. And if you can get a screenshot or more information, that'll help you massively. As we talked about earlier, if you master Git, right, master a version control system, can help hugely, especially when you need to find where specific bugs are introduced, right? If someone comes in with a bug and says, oh, Mary Jane from 4 months ago found this, and we only just read the email, well, what version was she on at the time, right? What version of the website was she running? What version of the app, right? That's where version control, getting good at it, can be really useful. And yeah, there's no secret to debugging. It just takes a lot of practice. So it's my last slide. A few last tips. For those of you who haven't, please get really, really good at the command line interface. I'll be blown away by how productive you can be and how fast you can be when you get really good at it. Second one, pick the right tool for the job, right? So I'll give an example. In the front-end world, at the moment, React is really hot. It's being used for every single project. But the truth is that a lot of apps probably don't need something as powerful as React to do the job, right? When there's other frameworks like Ionic or progressive web apps, which are just as easy to implement, if not easier, and the development time cuts down by a lot. So pick the right job, pick the right tool for the right job. My last tip is just stop trying to learn everything, right? You want to be someone who is resourceful and doesn't have to remember anything, right? The trick to working in IT, I think, is just to remember as little as you can, but to have a lot of resources that you can go and reference when you need to learn something, okay? At least that's what I get away with doing, and it seems to work pretty good for me. That's it. Thank you, guys. Questions?
What's the most valuable tip from the book that you didn't include in this book?
Most valuable tip from the book that I didn't include?
Yeah.
I don't know.
When was the last time you actually did get bisects?
Today. Today. The sad thing is the project is only 3 weeks old. Yeah.
Suppose you inherit a code base that all terrible error, it works and that's about it, though. Good thing you can say about it. What would you
prioritize fixing first?
What I prioritize fixing first? Okay, well, I'll tell you a real story. This happened recently. We inherited a code base from another company and with no Git history, and we were told it was the production code. When we started editing it and we pushed to production, people couldn't log in. We had not touched login functionality. So we had to obviously fix that because that was the first thing that came up. Sometimes it can be hard. A lot of people won't like to touch if code isn't working. I mean, like if something's not working, obviously you're going to try and fix that, right? But I think I would say start with something that you are pretty sure is going to work, even if it's refactoring methods to be slightly smaller. I think that's a really good place to start. Deleting code that you don't think, if there's methods that you have that aren't used, if you have libraries that aren't used, get rid of those. Anything that can make things smaller, I think is a good place to start. Yeah.
Do you ever have to convince your colleagues that?
Sorry?
Do you ever have to convince your colleagues to write codes?
Yes.
So how will you convince to resolve?
Sometimes you need to be like, you need to kind of say, hey, have you considered this? Right? You can say, if you're in your pull request, you can pass them a method. You can say, hey, have you considered this? You can say, what about if we did this way, right? We tackled this technical debt issue. We prevented a technical debt issue, right? I'm currently working on something to display error messages no matter what happens. And I'm trying to work with my colleagues to figure out the best way to do it. But I had to kind of say, hey, what if we did it this way now? We prevent technical debt in the future where if we want to use this one page to show error messages, we can do it easily. Yeah, gently, I think is the answer. What else? Yeah.
The design by contract, where does that sit?
Where does it sit?
Yes.
It sits in your code, in the actual, not in unit test code, in actual code.
So do you write one for each method?
You can do, yeah. Yeah. So the one I mentioned, which wasn't my demo, flow, you actually specify in each file if it's using flow. You can say, in the command you can go flow or something. It'll look at all your files marked with flow, and it will run against it. So you can run a routine on it to say, hey, run this function with these parameters, and you can check. And you can turn it off for production.
So it's not like extra overhead.
It can be if there's a few ways it's implemented, and in Flow that's the way they do it. In contractual, the one I showed, I think it's from memory it is at runtime. So it will actually work in development time, but it can often be turned off because you don't want it you don't want it running all the time, right? But it's a way for you, it's a heads up for you to say, hey, this doesn't work. It doesn't work the way we thought.
Like in Java, some of them probably saying this is sharp.
Yeah, that's right.
You actually use design by contract, because I imagine if you're using that, some of your colleagues probably aren't, and then we can confuse it.
So it's a powerful tool, but you can't use it in a project where people don't want to use it. You have to decide up front, this is how we're doing unit tests, this is how we're doing CSS, this is how we're doing X, Y, Z, right? If you don't have that at the beginning, it's hard to implement later. Something I encourage, but to answer your question, yes, we are. So there's a project we're working on in React where there's some design by contract implemented into the library itself. Way to check if this works where it should. So if you have some HTML, can you check, hey, does this button, you must pass it a property, must give this form. Right, and it tells you straight away if someone's violated it. So yes. Yeah.
Did you ever write code thinking how the person doing the pull request review would write it?
Sure. You should think about try to think about what could break, what could change. If I have a method, for example, right, how could it break? Right? How could someone call us and it not work? If someone comes to my code, can they see exactly what's going on without needing to read anything else? If they see my method, can they see exactly what it's doing? Is it expressive? Right? Does it? So clean code is a book you should read if you're interested in that kind of topic. But
So I'm a C developer, and we have a bunch of standards and namings methods that we can use for these. Is there anything like that, like any standards that you follow at work or JavaScript?
We should. But yeah, so things like naming conventions. So that's something that we actually, the protocol now we're actually looking to do to start doing this. So yeah, you should agree on things like we're using wrapper or container. If it's a method that is changing state, it's going to be called set such and such. That's things like that. Yeah. Cool. Thank you.
Cool. Thank you all for coming. I think there's still a couple of slices of pizza left, so feel free to eat that and chat amongst yourselves. We have the space until 8 o'clock, so feel free to network and ask questions. And once again, thanks to Xero for the venue and thanks to Ben for the Thanks, that was great.
Thank you. Thank you.
I did seem a bit nervous at the beginning about you sort of the results and some